Let's start by thinking about a cube that has a volume of 27 cubic inches. If you want to know how long each side is, think about the fact that you multiply the three equal sides together to get the volume. So if I want to figure out how long each side is, I need to figure out what times itself 3 times gets me 27. So I'm going to do the cube root of 27 and get 3 inches. If I'm going to simplify some radicals that aren't necessarily square roots, I'm still going to start by kind of thinking about a factor tree. So if I'm doing the cube root of -8, I need a number that multiplied times itself 3 times gives me -8. And -2 does that. Now the negative sometimes is a little bit confusing because I know you can't do square roots of negative numbers because no negative number times itself gives you a negative. But if you take a negative number times itself 3 times, you do get a negative value. So you can always think about cube root of a negative as like the cube root of the positive number times the cube root of -1. And -1 times -1 times -1 is -1. So its cube root is -1 as well. If you look at the cube root of 52 and try to break it down, you're going to get 2 and 26 and then 2 and 13. But it's a cube root. There aren't any factors that are being multiplied times themselves 3 times, so it's simplified as far as you can go there. If you have some variables, same idea. Look at the index on your radical, and if one's not written there, like this one, then that just indicates a square root. And then however many factors you need to take your root, so in this case 2, because it's a square root, I can do square root of 2 groups of y's and 1 group of x's, so I'll have xy squared on the outside of my radical, and then times square root of c. D is the 5th root, so I would need 5 factors of the same number before I can actually do a 5th root. So -8, I'm going to break down into 3 factors of -2. And then x to the 3rd, but there's only 3 x's. Y to the 5th, oh, that's a group of 5 y's right there. And z to the 7th, I'm going to think of as one complete group of 5 factors of z, and then 2 more that don't form a complete group of 5 factors. So on the outside, I can take y and z, and then on the inside, I have the 5th root of -8 x cubed y to the 2nd left over. We're going to multiply some radicals together. So first thing I'm going to do is just rewrite this as the 4th root of 8 times 16 combined. I'm not going to multiply 8 times 16 together because then I'd have to create a factor tree for a larger number. I'm just going to break them down individually. 8 is 3 factors of 2, and 16 is 4 factors of 2. And then if you look, you have one complete group of 4 factors of 2. So you can take the 4th root of 4 of those. 4th root of 2 to the 4th would just give you a single 2 on the outside. And then 2 times 2 times 2 left on the inside, which is 8. Don't forget your index on your radical, that little 4 right there. Now you have some values on the outside as well. So I'm going to go ahead and multiply those together first. So 2 times 4 gives me 8. And then in terms of cube roots, I have cube root of 9 times 15. And again, I'm going to just leave those and then break them down individually into 9 is 3 times 3, and 15 is 3 times 5. This is a cube root, so I can take the cube root of my 3 factors of 3 and have a 3 on the outside that I need to multiply times the 8 that's already out there. Don't forget about it. So I'm going to end up with 24 times the cube root of 5. Let's throw some variables in there. So actually variables are almost easier than dealing with numbers. So if you think about multiplying x to the 4th times x squared, you have a total of 6 factors of x on the inside and then 5 factors of y. If you want to list them all out, sometimes I do because it helps you see it, sometimes I don't. But looking for groups of 3 factors, I have 2 groups of 3 factors of x, so x squared on the outside, and only 1 of y. And then there's a y squared left over. All right, it's time for adding and subtracting. So reminder, you can only add and subtract like radicals, and that means they have to have the same index and same value inside of them. So first things first, let's break down this cube root of 54, because to start with, it doesn't appear any of these are like radicals. But if I break down 54, I can do a cube root of 3 times 3 times 3 and have 3 on the outside. And then I have 3 cube roots of 2 plus 4 cube roots of 2 that I can actually add together. So 3 of them plus 4 of them gives me 7 total cube roots of 2. And then I can't add the square root of 2 because it's a different index. It's not the same thing. So variable-wise, again, break down your radicals first to see if you have any like radicals. So I can do the square root of y squared and just get y on the outside. And then y times the square root of x minus 6y times the square root of x, you can subtract them. And think about y minus 6y would be negative 5y, square roots of x.